Okay, so let's do a couple of more quadratic equations. Let's start off with maybe x squared minus 2x plus 6 equals minus 2x plus 2. I want to solve this. Let's try moving things over to the other side. X squared minus 2x plus 6. Well, I add 2x to both sides. I subtract 2 to both sides. And now this is what I get. So, I have x squared. Well, thankfully that cancels because I have a minus 2x and a plus 2x. And then I have plus 4 equals 0. So when I first look at this, I might be trying to fit this. I might be trying to say, hey, is this a difference of squares? I have a nice formula for that. No, it's a sum of squares. And we don't have a formula for that. As a matter of fact, I know that 4 is always positive because, well, 4 is a positive whole number. And I know that x squared can never be negative. It's a non-negative number. So if I add a non-negative number to a positive number, I'm not going to get 0. So this actually has no solution. So something to look out for always is a sum of squares. Because if a sum of squares is 0, well, the only way that could be 0 is if they were both 0, and 4 is not equal to 0. So that's something to look out for. You might wonder, well, are there any other situations where we might get no solution? Because it seems in the examples we've already done, the norm is to have 2 solutions. Aside from the example where we did x squared equals 0, our equations each had 2 solutions. And now suddenly we get one with no solutions. So is there a way to know ahead of time whether there's going to be no solution? Well, the answer to that is yes, but let's do a few more problems before we try to answer or address that. Let's try this one. So this might not immediately look like a quadratic of any form. There's no x squared to start off with, but we're going to get an x squared if we multiply these two here and here. So let's try to simplify. If I try this, I will get 5x minus x squared minus x is equal to 4. I could simplify this right off the bat. 5x minus x is going to give me 4x. And let's actually move everything over to the right. That would give me 0 is equal to x squared minus 4x. And we still have this 4 over here on the right. Okay. So very similar to what we had here. That gave us no solution, except now we have this minus 4x. So even though this is positive and non-negative, maybe things balance out a little bit. Let's see whether we could solve this. Some of you may immediately see something we could do because this fits a form that we've seen before. Remember, or maybe we don't remember, that we did have something, a formula for x squared minus 2a plus a squared. That ended up being x minus a squared, because that gave us an x squared. Then we'll have minus ax, 2ax here. We'll have minus ax 2 times. And then we'll have a minus a times a minus a, which is going to give me a plus a squared. But let's say we don't remember this. It slips our mind. Can we solve this just by factoring? And the answer is yes. So I have a 4 here. You might want to try 1 and 4. If we try 1 and 4, any combination of adding or subtracting a 1 and a 4 is going to give us an odd number. 4 is not an odd number, so that's definitely not going to work out, so I need 2 and 2. In order to get a plus 4, I need these to be either both plus or both minus. Well, both plus would not give me a minus here, so let's try that, and that works nicely. Minus 2x minus 2x gives me minus 4x. So, what do I have here? I have a product equal to 0. And a product's equal to 0 when one of the pieces are 0. that means we know that either x minus 2 equals 0 or x minus 2 equals 0. Well, either way, x is going to be 2, and that is our only solution. So, we've looked at an example with no solution and an example with one solution, and our previous examples have had two solutions, or several of our previous examples have had two solutions. Just something to notice moving forward, we might want to ask how many solutions a quadratic equation could have, and we will address that as we move on.